Hey, so this tutorial is going to be on reading binary. Basically, learn how to count and read in binary. So we're going to have to start with the basics. Before we deal with actual binary, we'll deal with the normal English language. So with the numbers we deal with every day, we have 10 symbols that represent up to 9 objects. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So with these we can represent up to 9 objects and individual objects, 9 individual objects. And when you want to represent a 10th object, you don't have a unique symbol. We have to start really recycling the numbers we've had before, and using this process we can represent an infinite number of objects. So the trick with the that we do, you learn in grade school, is that when you read the number, you say you want the number 12. There's no number to represent 12, no specific symbol, so we have to use the old one. So what we do is we place positions to represent groups. So the number 12 says that you have two individuals and one group of 10. And this may seem very basic and maybe a waste of time, but it's kind of key to understanding binary, and it will make things that you have to learn later much simpler to understand. So two individuals, or the ones group instead of individuals. So for larger numbers like 234, let's say, it's obviously 2 groups of 100, 3 groups of 10, and 4 individuals. And as you go on, you add group of thousands, groups of tens of thousands, things like that. So this is looked at actually as 2 times 100 plus, oops, there's a plus there, 3 times 10 plus 4 times 1. And, here's ones, tens, hundreds. But now, instead of looking at it like that, as ones, tens, and hundreds, I want you to look at it as something else. So we know that, let's take the number 5,000 or 54,362. Let's look at this. So the ones, let's look at that as 10 to the 0. And we know that, or if you don't know, now you will know, any number to the power of 0 equals 1. So this is the same as the ones group. So this is basically 2 times 10 to the 0 instead of 2 times 1. And we are not complicating things for no reason. This actually will make binary easier to understand. So every time you move over a position, you increase the power by 1. So this is the tens group, so we call this the 10 to the 1. And this will be the hundreds group, which is 10 to the 2. Thousands group is 10 to the 3. And the tens of thousands group is 10 to the 4. And that basically says 5 times 10 to the 4 plus 4 times 10 to the 3 plus 3 times 10 to the 2 plus 6 times 10 to the 1 plus 2 times 10 to the 0. This gives us 54,362. Now, applying this to binary. Okay, in binary, we only have 2 symbols. Oops. Can't do it straight there. So in binary, we only have 2 symbols. A symbol to represent no objects and a symbol to represent one object. We call it 0 and 1. So with binary, you have, okay, I want to represent one object. I want to represent no objects. Now I want to represent one object. Now we have an issue. If you want to represent two objects, we don't have a symbol to represent that object, so we have to recycle what we have. So we're going to use the same concept as before that we've learned from a long time ago and say, alright, we have 0 individuals, and since I need to represent 2, I'm just going to move over this one space over, and call this a group of 2's. Alright? And then if you want to represent the number 3, so this equals 0, this equals 1, this doesn't equal 10, this equals 2, because this now represents a group of 2. If you want to represent the number 3, we're going to do 2 plus 1. We don't need a new group because we already know we can fill in an individual here. So 1, 1, that's not 11, this is 3. And this is, if you want the number 4, we can't do anything else. We only have 2 symbols. So we have to make in a new position. And we'll say this is one group of 4. So this is a group of individuals, this row right here. This row right here is a group of 2's. And this new row is going to be a group of 4. So if you want to represent 5, you just add one individual to it, a group of 1's. If you want to make it 6, you do 1. You can't add another individual because you only have up to 1. So you add a group of 2. And if you that's all you need to make the number 6. If you want to make the number 7, a group of 4, a group of 2, and an individual gives us 7. And of course, since we've run out of space, you need to make a new position, and we will call this new position a group of 8's. So you notice something, that every time we have 1, 0, 1, 0, 0, every time we have to start in a new group, it's actually doubling. So we have 10, 4, 8. And before it was each position with this system right here, each position was a group of 10 to the x. With binary, since we don't have 10 symbols, we actually have 2 symbols, each position is a group of 2 to the x. So this is how to create it. But if you wanted to read binary, let's make up a random string, and I'll be able to come up with it, what it actually represents. So 1, 0, 1, 1, 0, 1, 1. Okay? We know to start with the individuals. So this is 2 to the 0, this is 2 to the 1, this is 2 to the 2, this is 2 to the 3, this group here is 2 to the 4, this group is 2 to the 5, and this group is 2 to the 6. So what this tells us is that we have 1 times 2 to the 6 plus 0 times 2 to the 5 plus 1 times 2 to the 4 plus 1 times 2 to the 3 plus 0 times 2 to the 5, I'm not going to include those, plus 1 times 2 to the 2, 2 to the 1, 1 times 2 to the 1, plus 1 times 2 to the 0. And we know that 2 to the 0 equals 1. Alright, so these numbers, 2 to the 6 is actually 64 plus 32 plus, 2 to the 4 is actually 16. Yeah, 2 to the 4 is actually 16. So let me erase that. So 2 to the 6, 64 plus 16 plus 8 plus 2 plus 2 to the 0 is 1. 1 times 1 is 1. 64 plus 8, 16 plus 8 plus 2 plus 1. So this string 101111 represents the number 91. And that is how you read binary, and that's how we're going to use how to read binary to help us in the next video to create more binary. and it'll be easier to create more strings once you learn and practice how to read this.